what teaching's like. All right, being positive here. Now, when you see an exponential equation, what should you instantly think first, right off? Make the bases the same. Equal bases. He said it the mathematical true way. Everybody, what do you do when you see exponentials? Okay, what do you do when you see exponentials? God, I wish I was a Marine drill instructor right now so I could yell at y'all. Yeah, you make the bases the what? Same. 6, 3x minus 4, 6 squared. And I'm going to write in a step that you probably don't need. And then I'm going to get 6, 3x minus 4 equals 6, 4x plus 8. And everybody forgets to distribute the 2. Use a little distributive property there. Now, somebody said, could you turn the 6 over here into 36? Yeah, but you're going to have a fractional exponent. Don't do that. Turn them into the smaller things. 3x minus 4 equals 4x plus 8. Negative x equals 12. X equals negative 12. All right, so pretty straightforward. Nothing that weird there. Make the bases the what? Same. Okay, that's 19. Now, I'm going to skip down, and this one may be too easy to work, but I'm going to work 26. I'm going to work 26. Yeah, I'm keeping a list of which ones I'm working. That way, whichever kid says, Mommy, you didn't do one of those. Okay, 26, log base 2 of x. Log base 2 of x equals 4. Okay, folks. You have just a log on the side. All right? You got one log and then it equals a number like that. Use rule 5. Use rule 5. You put a 2 here and a 2 here. Because 2 raised to the log base 2, those are inverse functions, and it will just leave what? X. Now, the scary part is your science teacher doesn't show you how to get from here to here. They just know it works. They know it's worked for ages. But that's what they're doing. They're putting a 2 here and a 2 here in their head, and then they're just writing down what? That. Okay? I'm just showing you how to get there. Because everybody, hopefully you remember it. And then 2, you're going to get what? X to the 16? And there you go. Now, before we start the next part, I want to do a little fine-tuning about logs. Okay? Now, I've already talked to you about this once, but I'll talk to you about it again. Any question on those two? Anyone? All right. For right now, we only know how to take the log of positive numbers. Now, I'll be honest. You can take the log of a negative number. It's just we don't know how yet. Okay? But you can. But for right now, if we have logs, we have to be taking the log of a positive number. Whatever is in that set of parentheses has to work out to be what? Positive. Now, here's what I want to show you. If I had that, and I told you I had these 3 answers, x equals 10, x equals negative 10, and x equals 3. And I ask you, which one of them really work? Which ones really work? Everybody, oh, the negative 10 doesn't work. Wrong. That's on the ACT test. They have this on the ACT test. And what happens is, you have to put the number back in here and see if it makes this negative. Does everybody listen to this? You have to check to see if it makes this part negative. Well, put the 10 in there. 7 minus 10 would make what? -3. Can't use that one. Now, if you put negative 10 in there, 7 minus negative 10 would be a positive what? That's a good answer. Okay? Put a 3 in there, you get a positive 2. That would be a what? Good answer. This answer is called an extraneous solution. It's called an extraneous solution. Okay? What it is you can't use it for real numbers. To be honest, if you already knew how to take the log of negative numbers, you could use that and it would work. All right? But for right now, you're not supposed to know that. So it's not that you get a negative down here as your x value. So what I'm saying is, when you have these, you got to test them to make sure that you're not taking the log of a what? Negative number. It's not that it's negative down here, it's that it's negative when you test it in the original. Everybody listening? Now, just for fun, I will go ahead and tell you the natural log of -1, even though you're not supposed to know it yet, and it'll help you understand why we're not doing it. Natural log of -1 is equal to pi times I. Notice what we just ran into? We got that little I in there. Yeah, it's an imaginary number, it's a complex number. It's the same situation as when you were trying to take the square roots of negative numbers. All right? And you don't have to know that yet, but one day you will be introduced to that. So don't say you can't take the natural log of a negative number. Say that you can't yet. All right, now I'm going to work some more problems. We're going to hit the new stuff. Here we go. I'm going to work number number 41. Work 41. 41. Log x minus 3. Log x minus 3. Plus log x plus 3 equals 4. All right. Now, I'm going to tell you something. You remember the rules 6 and 7? Okay. The catch is you cannot use rule 5 unless you just have one log on each side. You cannot use rule 5 unless you only have one log per side. You can't have 2 logs and use rule 5. Fair enough? You can't have 2 logs on the same side. You can have a log here and a log over here, but you can only have up to how many logs on each side to use rule number 5? 1. Why do you think I just said at the beginning of this, rule 6 and 7? Because what are you going to do right here? Yeah, you're going to combine them. You're going to use rule 6. You'll start off right there and use rule 6. Because you want just one log on each side at the most. So I'm going to get log, and then I got to multiply x minus 3 times x plus 3 equals 4. Go ahead and multiply that out. And when you multiply that out, you're using distributive property. And you get x squared minus 9 equals 4. Some of y'all might say that you use FOIL. FOIL is a 4-letter word. It's not a math word. 4-letter word that begins with F. Don't use it. So the deal is you're using what really are you doing? Distributive property. Say it.
Distributive property.
Use full in your college classroom, you're going to be in trouble. What number is understood to be right here? 10. So there's understood to be a 10 there. What am I about to put here? 10. And what am I about to put over here? 10. And I'm going to get x squared minus 9 equals 10 to the 4th. Okay? 10 to the 4th. X squared equals 10 to the 4th plus 9. going to be x squared equals that, Mr. Evans. X squared. So x is going to equal the positive or the negative square root of 1,000. Okay, 10 to the second is 100, 10 to the third is 1,000, 10 to the fourth is 10,000. Okay, there you go. Now, it could be what? Positive or negative. But I got to be real careful. I got to test my answers. Now, it could be a negative number and still work here, right? It could still be negative. But if you put a negative in here, a negative minus a number is still going to be what? Negative, right? Does everybody agree a negative minus a number is still negative? Now, I don't have to know the exact value of it. I just got to know that it's negative. So the only good solution is x equals the square root. Now, and I think that is, I don't think you can factor that or reduce it or make it look any prettier. All right? Because I looked at the key today. Dr. Sisson's wife is Dr. Sisson too. And she's a computer science professor. And she probably thinks decimals are okay because he actually put a decimal answer for this in his book. But we don't do that. We're going to leave radicals. Okay? Now, on your test coming up, you will not need a calculator. No calculators. You're learning how to do logarithms and exponentials without one. Then we'll go back and talk about how to do it with one. All right. That's 41. Look down the page. And I am going to work 43. 43. I'm going to go over here and make that page a little bigger so I can see it. 43. And don't panic that there's little pi's there. It's okay. Pi is just a number. Not Strawn's pi. I wish it was. Okay, number 43. Log base pi of x minus 5.
What's that x represent? What's the base of x, isn't it?
It's base pi. Yeah. It's a little pi down there. And the only reason I know is I've walked over here really close to it and looked at it. And I can look at it in the book. So I can cheat and look at it in the book. It's a pi. Yeah. All right. Plus log base pi of x plus 3 equals log base pi of 1 minus 2x. Now, catch is you can't use rule number 5 yet. What do you have to do to these two right here? Combine them. Use rule 6. Rule 6. Use rule 6. Combine them. Log base pi x minus 5 times x plus 3 equals log base pi of 1 minus 2x. And probably what you should do is go ahead and do what? Multiply these out using distributive property. Log base pi x squared minus 2x minus 15 equals log base pi minus 2x. And here's the wonderful thing, and the reason that pi doesn't hurt you, or the reason it doesn't come out and be a problem, is because you're about to use rule number 5. And what are you about to write below each one of those to use rule number 5? Pi, right? Pi. And that will take care of the log base pi's. Now, so you're going to get x squared minus 2x minus 15 equals 1 minus 2x. X squared minus 16 equals 0. x equals a positive 4, or x equals a negative 4. And I hope he's not the guy that wrote the book that says every time you get a negative. Okay. Positive 4 will not work there. Does everybody agree a positive 4 will not work there? Is everybody okay that positive 4 will not work there, right? Is that cool? Somebody says, Mr. Evans, positive 4 won't work over there either, will it? Okay, so positive 4 is not a good answer. Negative 4. Well, if you use negative 4, that's going to be negative, and that's going to be negative, right? That won't work. Neither one of them works. Empty set. Empty set. And this is like an ACT question, where they've got the two answers down there, you know, A, and then for B, they got just the 4. Because a lot of people are going to think just the 4 works because the 4 is positive. But it doesn't work. That's an empty set. I'm glad I worked that one. Now, next bit of news. Notice, bunches of logs. We combined them into one log. Right? And then you just had a number over here which made it a little different. Here, you got a bunch of logs, you still got to do what? Combine them into one log. To work these equations, a big thing that you have to remember is to always combine them into one log. Okay? I think we may want to do 52. Let's see. Yeah. Tell you what I'll do. Yeah, let's do 52 because it's got that 2 in front. Let me look at 52 right quick. This will be the last one I'll work for you guys. Then I'm going to put you to work. 52. You cannot use Rule 5 when there's a number in front of your logarithm. Okay, 52. 52. 2 natural log x plus 3 equals natural log 12 minus x. All right, is that 12 minus x or just 12x? 12x. All right. See, I want to put an e right here, but I can't because there's a what right there? 2. So what I'm going to do is I'm going to move the 2 back in and make it a power. Is that okay? What's understood to be right here is understood to be a little e, right? So I got to need a big E, using Rule 5. And I get x plus 3 squared equals 12x. Folks, this is back to algebra 2. Is that all right? That's back to algebra 2. I ought to just quit now and let you finish it. See, that's what would happen if you were taking college algebra. The guy goes, oh, that's high school math. And he stops writing. So don't do that to us, Mr. Evans. Well, what you need to do is you got to square this out. And when you square it out, if you have to, you write it out twice and multiply it out using distributive property. But you have to square that out. And when you do that, you get x squared plus 6x plus 9 equals 12x. And if you need to, I'll write it. X plus 3, x plus 3 equals 12x. So you have to multiply that out. Now, ladies and gentlemen, when you see x squared, make it equal 0 and then factor. Okay, if you cannot factor, I will go back and chat with your Algebra 2 teacher and your Algebra 1 teacher about lowering your grade. All right? You get x minus 3, x minus 3, x equals 3. And 3 works there because it makes it positive. 3 works there because it makes it positive. And we're happy. Okay? Now, factoring trinomials. if you need to, write factored trinomial. But you might want to put factor right there. If you don't know how to factor, I can help you with it. Can't help you during class like when we're teaching this, but I'll help you with it. If you need help factoring. And you got to be able to factor fast. All right? Got to be able to factor fast. Now, that was 52. Here's what I want you to do. Today and tomorrow, you need to be in this section. This is the last assignment. For right now, this is the last assignment in exponentials and logarithms. I'm going to give you some more problems on Wednesday to go with this. But what I would do today is I would hit this hard today, and I would also work on it tomorrow. This is your this is for the rest of today, and then this is your tomorrow. You're only working the ones that are circled, because this has the calculator required problems and the non-calculator problems all mixed together. I'm just doing no calculator, and then we'll start on calculator later. All right? So yeah, you can just write in it's Sisson 5.5. The answer key, I've got it open to Sisson 5.5 right up here. I'm going to cut this off